Thank you. The next speaker is Professor MacGregor from Cambridge, with co-authors, and the topic is prediction, attention, and memory. What disfluency tells us about the comprehension of spontaneous speech. Is it on the desktop? Yes. Right. Additional cognitive load. Thank you.
I think that was okay on test.
Thanks. Okay, in this talk I'd like to argue that disfluencies in speech, they're not just noise, they're not uninteresting for language comprehension. In fact, they're an inherent part of spontaneous speech. They have interesting effects on listeners' prediction, attention and memory, and this can tell us something interesting about language comprehension. So to put the work in some context, we know that understanding spontaneous speech is actually quite different from the kind of speech that we typically encounter in a psycholinguistic experiment. So out in the real world, we have to understand speech, which may be quite noisy. Perhaps there's other conversations going on at the same time as the one that we're engaged in. We might be listening to speech in noise, for example at a party or a train station. We have to understand speech whilst doing other things which may demand our attention, maybe driving a car. And usually we understand speech in an interactive dialogue situation. There's also differences in the signal. So we have to understand speech by a speaker whose accent may be different or unfamiliar. We have to understand speech which may not be grammatical. And what I'm going to focus on, we have to understand speech which will include disfluencies. These are the kind of disfluencies that we all use in everyday conversation. So I'm not talking about disfluencies when people have a specific language impairment, for example. So what are disfluencies? They've been defined as phenomena that interrupt the flow of speech but do not add any propositional content to an utterance. So there's a number of different types. We've got filled pauses such as or so on, silent pauses, repetitions, this could be of single phonemes, words or whole phrases, prolongations, so in English a pronounced a or the pronounced the, and these often co-occur with other types of disfluencies. And then we've got outright error repairs, which may or may not be considered a type of disfluency. So we know that disfluencies are actually very prevalent in spontaneous speech. It's been shown that they affect around 6 to 10 words in every 100. Now traditionally, in the psycholinguistic literature anyway, disfluencies were considered noise in the signal. So for example, computational approaches to speech recognition really focused on how to identify the disfluencies and remove them from the signal, rather than incorporating them into speech recognition itself. But I think approaches to the study of disfluency are now changing, and people are acknowledging that in fact they're an inherent part of the speech signal. The speech comprehension system must be dealing with them in some way, and in fact they can have some interesting consequences for listeners. So as I said, I want to argue no, they're not just noise. I'm going to focus on 3 types of disfluencies: filled pause silent pauses and repetitions. And in our research we have looked at the effects of processing of these types of disfluencies themselves, but what I think is actually more interesting, what I focus on today, is how these disfluencies affect the processing of subsequent words in speech. So in this way we can vary the fluency of speech context. It can be fluent or disfluent, contain one or more of these types of disfluencies, and then we see how the processing of subsequent information, which we keep constant across conditions, we see how that varies. So turning first to prediction, we know, and it's general consensus now, that listeners continuously make predictions during speech comprehension. They do this at a number of different linguistic levels, making use of all kinds of different sources of information. But most of these studies have been done where speech is fluent. So we know that listeners can predict upcoming speech in optimal circumstances, but as I said, circumstances aren't usually optimal. What I want to focus on, how are predictions affected by disfluency? So reasons why we might expect disfluencies to affect prediction. We know that the distribution of disfluencies in speech is not arbitrary. They tend to occur when a speaker is having some kind of production difficulty, and this can be at different stages of the speech production process. It's been shown that speakers are more disfluent when they're less certain of what they're going to say next, indicating that disfluencies are associated with conceptualization difficulties. We see more disfluencies before content words than function words, before unpredictable as opposed to predictable words, before low frequency as opposed to higher frequency words, all giving us some indication that disfluencies are associated with lexical retrieval difficulties. We see more disfluencies at the beginnings of clauses and before a speaker utters something that's more syntactically complex. And it's also been shown that humanities lecturers are more disfluent than those in the social sciences and sciences. This is not a personality difference, but apparently due to the number of different ways that a person would have to speak about an item in the humanities subject. There's more lexical choices in this situation. So what are the effects on listeners? In behavioural tasks, it's been shown that listeners respond faster following a disfluency when to an item that is more complex than simple, that they're more likely to first move their mouth towards a new item in the discourse than to an item that has been previously mentioned before. There's a set of studies using the visual world paradigm showing that listeners are more likely to fixate first to new items in a discourse than old items, and to unfamiliar than familiar items in a discourse, all suggesting that listeners are somewhat sensitive to the probability that disfluencies occur before items that are more difficult for the speaker to say. There's a recent study showing that this bias may emerge around the age of 2 years old. So it's been shown that toddlers, when looking at novel objects, they look more towards these novel objects when the speech from the speaker has been disfluent than when it is fluent. All these studies have used behavioural techniques or the visual world paradigm, produced interesting results, but they show that listeners can make predictions. Listeners' predictions following disfluency can change when there's information in front of the listeners, when they've got some clear set of objects about which they can make concrete predictions. What we've asked is how are predictions affected when there's no set of items in front of the listener, when there's more possibilities about what the speaker may say. So to do this, we've carried out a set of ERP experiments where we manipulated the closed probability of words and sentences. So in this way, we had sentences which ended in either predictable words, which would be easy for the listener to process, or less predictable words, which would be more difficult for the listener to process. And the difference between these predictable and unpredictable words have been shown to elicit clear differences in the ERP brain responses. Across our sentences, then, our predictable words also occurred as unpredictable endings to other sentences. And half of our experimental materials were disfluent. In this case, they contained an before the target word, and they also included some other featured disfluencies where it was felt to be natural for the speaker to produce them in this way. So the way that we set up our stimuli was to have a native English speaker come into the lab and produce fluent and disfluent discourse. So obviously this is not fully spontaneous speech, but it's an attempt to make our speech more spontaneous while maintaining some experimental control. We then spliced the same acoustic tokens onto the end of our fluent and disfluent utterances. The listeners just have to listen to the sentences for understanding while doing no other task. And we obviously presented these experimental materials interspersed with some filler items to mask the experimental manipulations. So this is the ERP result for a single electrode, showing that for fluent utterances, then the unpredictable words, as expected, elicited a greater negativity, typical of an N400, compared to the predictable words. What we were interested in, when these target words followed a disfluency, we saw a significant attenuation in the size of the N400 effect. In line with the possibility, in line with the proposal that following a disfluency, when there's no clear predictions can be made, then listeners tend to reduce the extent to which they make a specific prediction. Then the ease with which they can integrate contextually predictable or unpredictable words, that difference has been significantly reduced. Now, this result obviously raised a number of questions. One is the nature of the disfluent signal itself. So what is it about the disfluency signal that's causing the effect? One thing, we know that speakers are disfluent in many different ways. So we wondered, do other types of disfluency have a similar effect to an So we carried out the same experiment, replacing the first with a silent pause and then with a repetition. And the repetition was of the words immediately preceding the target word. In the case of the silence, we found that silence, like an attenuated the N400, suggesting that predictions are altered also in this case. However, repetitions showed no such attenuation of the N400 effect. So there's a number of possibilities to account for these findings. The first concerns temporal delay. So both silent pauses and filled pauses, they introduce the time delay before the onset of the target word and the offset of the context in which you have to integrate the critical information. Maybe just that having this additional time is a critical factor. And there's quite a lot of support already for the temporal delay hypothesis. It's been shown, for example, in some experimental setups that different types of delay, both linguistic and environmental sounds, can have similar effects on the kind of measures that have been looked at. Another possibility is to do with the acoustic distinctiveness. So both an and a silent pause are quite different to the lexical context of a normal sentence, whereas the repetitions contain lexical information themselves, and so maybe it's that's the important factor. Now there's mixed evidence for both these possibilities. Another possibility is actually to do with the function of the particular disfluency. So silent pauses and filled pauses, they've been shown to be clear indicators of upcoming problems in speech. A repetition can function in this way in some cases, but more often than not, and I think the case for our experimental materials, they're used as a continuation device to help maintain the flow of fluent speech after a covert speech error, for example. So it may be that in our stimuli, the repetitions do not give the listener any indication of any upcoming problems. There was no reason for them to change their predictions about what came up next. Of course, the good thing about ERPs is they enable us to look at changes over time. And so in the repetition experiment, it wasn't just the case that we found no attenuation of the N400. We looked further down the line after the N400 and found that in fact there was a change associated with the presence of the disfluency. We found a significant increase in positivity elicited in response to the unpredictable compared to the predictable words. This late positivity has been shown somewhat similarly in other experiments, which have suggested that it may be something to do with memory control processes. We think in our context that this positivity may reflect the listener's need to get back on track with some fluent processing after the interruption to speech. And this process may be more difficult when the particular word is unpredictable, when it fits less well with the context in which it needs to be integrated. Now, if this is the case, we might expect it to see it in other situations where there's interruptions. And in fact, we did observe this positivity in both our condition and in the silent condition. As well as looking at the online effects of disfluency processing, we are also interested in whether there's any long-term consequences for the way the information is represented in the listener's mind. So after presenting our listeners with these sentences, we gave them a surprise recognition memory test for the target words that they'd encountered in the first part of the experiment. So they saw visually presented predictable or unpredictable words, words that have been predictable or unpredictable in their context, and these that appeared in fluent or disfluent contexts. And these were interspersed with completely new words. They just had to respond old or new. Now, as expected, listeners were more likely to correctly recognise words which had been unpredictable in their context. But most interestingly, there was also an effect of disfluency. So words were more likely to be correctly recognised if they'd been heard in a disfluent context. Now, this recognition memory effect was also found. We also found it when our disfluent context had been included a silent pause, but we didn't find the effect in the case of repetitions. So it seems that ers and silent pauses can enhance recognition memory, but repetitions can't. And these results fit in quite nicely with recent experiments which had looked at recall memory of fluent and disfluent discourse. And it's been shown that ers and ums can enhance listeners' ability to correctly recall plot points from a discourse that they heard earlier, and as their control condition they used interruptions that were coughs actually. Now, a possible explanation for these results draws on attention. In some earlier studies, it had been suggested by a couple of authors, two studies, that attention may be underlying some disfluency effects. So in these particular studies, they were reaction time studies. It was shown that listeners were faster to respond to instructions to identify images on a computer screen, and they were also faster to recognise words in a word monitoring task when the critical target words had been preceded by a pause. It was suggested that this is due to heightening of attention caused by the insertion of the disfluency. We wanted to test the presence of attention, the role of attention in disfluency processing more directly. So we carried out an ERP experiment using the highly predictable materials from our first set of experiments. So we had sentences ending in predictable words. Again, half of the materials were disfluent and contained a disfluency before the target word. This time, we manipulated a portion of our target words so that they were acoustic oddballs. We've heard quite a lot about the oddball paradigm already. In our case, we created oddballs by manipulating the amplitude within certain frequency bands. These oddball target words, they could be easily understood by the listener, but they just sounded a little bit weird, like speech over a poor telephone line, for example. Now again, listeners just listened to the sentences for understanding. There was no other task, and we interspersed the critical sentences with some filler utterances. So here we can see the brain responses in response to the acoustic oddball in green relative to the control word. We see a typical MMN reflecting detection by the listeners of the acoustic oddball, and this is followed by a significant P300 effect, reflecting their orientation of attention to the oddball. Following the disfluency, there was still some indication of the MMN, but most notably, there was a significant reduction, there was significant attenuation of the P300 effect. In fact, we didn't find a significant P300 effect in this case. So at first glance, the results look reminiscent of the attentional blink effect, where we see an attenuation of the P300 to a second stimulus. But we think that the attentional blink effect isn't what's going on here, and there's three main reasons for this. So first of all, we'd already shown an attenuation of the N400 effect in this kind of context, and there's no reason, this hasn't been shown in an attentional blink paradigm before. The attentional blink is usually shown with maximal effect when there's a delay of around 300 milliseconds between the first and the second stimulus. In our sentences, then our disfluencies were on average over 500 milliseconds long, so there was quite a significant delay actually before the onset of the target word, the oddball, after having heard the disfluency. And finally, and I think most convincingly, we did again in this study find significant memory effect. So words were more likely to be correctly recognised if they'd been heard in the disfluent context. Now recently we've rerun these studies again, replacing the ers with silent pauses and repetitions. Still need to finalise the results, but it looks like silent pauses having a similar effect to an but repetitions are not. Okay, so I'd just like to sum up by saying that I don't think disfluency is just uninteresting noise. We've seen that when speakers are disfluent, then listeners' predictions can be affected. Listeners can make predictions that upcoming speech may be more complex, more informative, or maybe less contextually expected. When there's evidence available, for example in a visual world paradigm, they can make specific predictions still. But in the case where there's no information available, then predictions are simply weakened. We see that disfluencies can cause listeners to pay more attention to what's coming up next. And this attention has consequences for encoding the message, and thus we see later effects on memory. Following any interruption to speech, then it's necessary for a listener to get back on track with their fluent processing, and we can see effects of this in the ERP waveform as well. So in conclusion, I think disfluency has very interesting effects, and it can tell us interesting things about the way the comprehension system is able to deal with this noisy variable and spontaneous speech that we usually hear. Thanks to the people involved in these studies, in particular Phil, who carried out the first attention ERP experiment as part of his PhD, and thank you for listening.
Thank you so much. Andrew,
yeah.
first.
Right. Thanks very much. Very nice administration. Right. Cool. So of course you're using very regular disfluences that are commonly occurring in speech.
Mm-hmm.
So yeah, listeners pick them up and change their predictions. Have you considered using irregularities in speech channels that are not regular speech disfluences, trying to see whether it's a surprise effect or whether there's something speech specific that this disfluency communicate to the listener?
So in these data, you're thinking of like environmental bells ringing or this kind of thing?
Like that.
So we haven't done that in this set of studies, but other studies have used environmental noises as controls, for example, and in many cases, or in some cases, shown similar effects of this kind of delay to speech as well. But there are other studies that have used, and I think I referred to one, used coughs as a control, which, like disfluencies, add delay into the speech signal. They'd also be surprising. But in this case, specifically the recall memory of discourse, in this case, memory wasn't affected. Seems not to, but yeah. Stuttering. Mm-hmm. Yeah, so these studies are looking at the kind of normal disfluencies that we make. I think stuttering is a qualitatively different type of disfluency, and in addition to the qualitative differences, then there's also differences in the rate of these kinds of disfluencies as well. I think it's important to consider the rate with which disfluencies are occurring, and this isn't something that we've manipulated in our particular experiment, but yeah, surely it's important.
Any more questions?
I think I'm in full agreement with you about the role of disfluencies when a person speaks about disfluencies makes the impression as if he or she has learned it by heart or is sincere or something like that. But what about the amount of disfluencies? Are there any studies of there must be some threshold over which influences start being very irritating. There are some people who make UH or UM after each word that's a bit too much, and that must affect the attentional processes. Right?
Yeah, I think definitely, and as I just said, it's not something we have looked at. It's something that definitely needs to be looked at, because yeah, for sure, then your attention, it's not going to have the same effect on attention anyway, nor prediction if the speaker isn't using it in that kind of way.
I was also wondering about an opposite pole, like simultaneous interpreting, when you need all the scope of memory, attention, and speed.
Yeah.
So there is possibly no disfluency, but
yeah.
the same processing, the same type of processing. Also.
Yeah, I think that's an interesting one. I think maybe we could use the late positivity effect that we were looking at, that we suggested maybe to do with memory control processes, getting back on track, the effort that's involved in having to recall what you heard earlier and then having
the delay. It goes on.
Yeah.
The signal is already there, the next signal is already there.
Yeah, so maybe we could look at some individual differences in this way, listeners' ability to cope.
It looks like it's one graph that the country not only was reduced to the uncomfortable words, but also was induced into functional words. So something like nail was no longer acceptable. I'm wondering if this difference was significant, if it was significant and impact or not.
So, first of all, the way we did our measurements, or the way we did our comparison, was to compare the difference between predictable and unpredictable in both cases, because we know that the baseline in the fluent case is going to be different to the disfluent case. So we set out, we didn't have the intention to want to directly compare what happens to the processing of predictable words in one case against predictable words in the other. But fitting it in with the previous studies, what we think is actually going on here is that you're making less specific predictions. Therefore, when you hear this predictable word in the disfluent case, then it's no longer being predicted, so it's going to be more difficult to integrate. So in a sense, I think, agreeing with what you're saying, it is probably the predictable word that's driving the attenuation in this case. But it was still a significant effect in the disfluent condition. Is that what you're asking?
Yeah, it was just interesting to see and on the predictable words.
Yeah.
But then there are really expecting different concepts.
Yeah. Yeah, this is what we think.
Yes, the last question. Because
I will be sincere trying to give guidance to the question, because you were talking about still responses with AQM, and you were not talking about still responses where the response is still by kind of word, like well in English or well no in Russian. Though it's more or less the same thing. So I do expect there will be any differences in having this just, phonetic, localized filling of this thought, or how they're sometimes called in Russian, parasite.
Yeah, like lexical fillers.
Yeah. So anything you expect here?
I think it would be a good way to get at a way to test whether it's acoustic distinctiveness that could be driving the effect. So if we could observe similar effects to and silent pauses with like, then it suggests it's not the acoustic distinctiveness, because like is a real word, as you're suggesting. We haven't done it with these lexical fillers, but it's on the cards, and it's definitely an interesting thing to say, thing to look at.
So the difference sometimes is filler for well, like, do, because of course markers.
Yeah.
It's sometimes hard to draw the distinction, where this filler becomes an important marker of a certain function. But functions are actually the same, like predictions.
Yeah, I think the same disfluencies or items, they have different functions depending on the discourse. They may have different functions between different speakers, so there's quite a lot of complicated issues going on.
Of course, once you have some semantic and functional differences, attracting attention, coming back to the point, some things like that. Probably those kinds of
Yeah.
Thank you ever so much.